In this video, we are going to talk about pericyclic reactions. These are reactions that happens, as you probably can guess from the name, through cyclic transition state. These reactions are interesting and different from other reactions in the sense that they don't happen with nucleophilic or electrophilic attack, and they don't involve great charges, changes in charges, and therefore they are not as affected by changes in the polarity of the solvent. So things that they have in common, again, they happen through a, say, cyclic transition state. So all of the electrons are moving around, so cyclic transition state, not involving formal charges, in nucleophilic attack, for example, and things like that. Right now, we are going to classify them, what types of pericyclic reactions we have. The first type here is called cycloaddition. And what happens here is two molecules. Molecule A is called, this is a diene, and we have seen dienes before. It's like two double bonds. So di for two, in. So diene in this is called a dienophile. And what happens in the course of the reaction this is, as I said, a cycloaddition. So two molecules, let's say molecule A, the diene, molecule B, the dienophile are gonna keep one molecule. They're gonna be added together to form now this molecule. Interesting here to note is that we have this bond is new. A new sigma bond, this bond is also new. So in this reaction, we are forming two new sigma bonds. Right, so and this is a cycloaddition. Now here, the other type of reaction is called electrocyclic. And let's write that, electrocyclic reaction. As all the pericyclic reactions, these involve a cyclic transition state, and we're just moving the electrons around. Here, what's happening in the electrocyclic reaction is mostly ring closing and ring opening. So we're gonna do this. So notice that I'm moving 6 electrons around, 2 and 2 and 2, right? What is the result of that reaction? So here I have, this molecule, if I do it in the extended form, notice that is 1, 2, 3, 4, 5, 6. So this is hexatriene, but it's like folded over. So these we call the SC's configurations. This is probably easier to see here in this compound. This right here, notice, has 1, 2, 3, 4 carbons. This is butadiene. And the preferred conformation of butadiene is that. This conformation is not the reactive conformation for the cycloaddition, but it is the most stable. This is the S strands, and this is the SCs. So what I wanted to see is that this molecule is the same as that, but when we're doing these reactions, we're going through a cyclic transition state, so we're going to reorganize that. We're gonna draw the conformer that is reactive, and that is in that folded conformation. So when we do this reaction, then what are we forming? We're making a new sigma bond here. Let's just draw the skeleton and let me go over that. So what is new here? This bond, right? So we have one new sigma bond here. And so that is electrocyclic. Electrocyclic reactions can happen both ways. So this, if it happens the other way, we just draw the arrows the other way around and we break this bond. We move that. Again, in a cyclic transition state, And notice if I do the after doing this arrow is that. So this is electrocyclic ring closing and ring opening. There are ways in which we'll do that, but this is, we'll do in a separate video just about electrocyclic reaction. In this video, we're just mentioning types of pericyclic reactions. So first type was cycloaddition, adding two things and forming one. And as we see here, we're forming two new sigma bonds. Electrocyclic, though, we're making one new sigma bond when you're doing the ring closing, or you're breaking the sigma bond when you're doing the reverse reaction. The third type is called Sigmatropic rearrangement. Sigmatropic rearrangement. And what happens here, and I'm going to add a substituent here so that we can explain better this. So say now in this rearrangement, what we're doing is we're closing that. So now in this bond, we're creating a new, in this reaction, a new bond here. And let's draw the product. This is a new bond, and the bond I broke. So notice this bond, let me just do a wiggle line here. Here we're breaking that bond, and we're making this bond is new between this and that. So this bond is broken. That's a double bond, same with the same color. All right, so that's the new bond. So if we didn't have that substituent X, the two molecules will be identical. And there is, in terms of enthalpy, there's not much change because here you are breaking a sigma bond, forming a sigma bond, back and forth. So changes in enthalpy here are small. So these are the essential, the three type of pericyclic reactions. And in another video, I'm going to talk more about the thermodynamics of the